Okay. So you have, no, you're fine. Go ahead. I can yell over that. I just want them to stop talking. You picked up 2 pieces of paper. So we're going to start with the gold one. This is from 213 part 1A. The good news is I didn't teach you anything wrong. That's not why we're revisiting it. We're not revisiting for me to go, whoops, let me reteach it. That's not this at all. But I have it written in. The front is exactly like it was. The back, they're partly done. Do not get ahead of me and go and solve them because we are looking at this different. That's why we are revisiting this, okay? So this is going to go on page 74 when we're done. You can put in parentheses page 70 because that's where the original is, right? So what I did was I took my notes and I just I backed up some and erased some steps. So the front, exactly like it was, talking about our properties of exponents and logs and how to rewrite them, blah, blah, blah. This lesson was on solving the equations with one log. I could have taken this same thing that I'm trying to do with y'all and did a different lesson. This was just a good one that had good questions and kind of made sense. So same instructions, whatever. All right, so flip it over. You have some room at the top. We're going to write some stuff at the top first as little reminders. If I have log base b of b, what does that equal? 1. Okay. So then comma, if I have log base b of b to the x, let's talk about this. We're going to talk about it without writing down all the steps. What I could do, stepwise, if I was going to show all my steps, is this x can come out in front and be multiplied. We agree with that? So it would be x times log base b of b. Well, we just said log base b is 1. Like log base b of b is 1. So if I take that x out into the front, then I would have x times 1. So this just gives me x. So log base b of b, I know the words that y'all like to use is they cancel each other out. Sort of. I mean, it's not canceling like canceling out 3's when I'm dividing, but essentially it goes away. It's not magic. There's no magic where the x just gets to jump out. There are steps. We just don't have to do the steps. Does that make sense to you? So log base b of b, if it's just plain, it is just 1. But if there's an exponent there, it's whatever the exponent is. Okay, we good on that? All right, so then going the other way, if I have b to the log base b of x power, again, there's steps. I could take the log of us. I could do a few things, a few steps, but I'll just tell you what happens. If the base here and the base here, if they match, and there's nothing in front of it, nothing being subtracted or whatever, then essentially those sort of, quote, cancel each other out, and you're left with x, okay? They have to match, though. And that right there, that's going to be very important in what I'm about to show you. Because we solved these by taking exponentials, converting them to logs, or logs and converting them into exponentials. And there's more than one way to do this. The way we did it was the way you learned in Algebra 2 and most likely saw again in Algebra 3. But there's another way to look at it, kind of using these properties, which if you're doing equations, you can do it either way and it doesn't matter. With inequalities, which is what we're about to get into, it does matter. And unfortunately, I don't ever remember until we get to inequalities that, dang it, I wish I'd have started by teaching it the other way. So I'm going to show you this. I think you'll actually like it better, which is also another reason why I kind of wish. And it's the way you're going to see it in calculus, just because it's easier and simpler and all that kind of stuff. So we're going to start off by, this first one, A. So all I've done here is I just got these to the point where we were ready to convert. Okay, I just left the work there so we didn't have to spend time writing it all down. We're going to first write this one out like we would have, or like we did on the other one. The base is 4, so we would write log base 4. We would go around the equal sign of 9 equals x. Do we all agree with that? That's how it works, right? Nothing wrong with that. But now watch this. Instead, I know I'm going to end up with a log. The base is 4. Instead, if I do log base 4 of both sides, these essentially go away, like this right here. I'm left with x, and that equals log base 4 of 9. Okay? Do you see how it's the same thing, but it's on the other side of the equal sign? That's why it matters with inequalities, and we'll discuss that again when we get there. But you don't have to do them both. I'm just showing you the way you already made sense, and then the way that we're going to look at today. Okay? We good so far? All right. So if I look at this one, I've got this to a point where I have a variable in the exponent. In order to get the variable out of the exponent, I need a log. The base is 2. So I'm going to take log, oops, that would help if I had a different color. I'm going to take log base 2 of both sides. Log base 2 of 2 to the x plus 3 gives me x plus 3. And that equals log base 2 of 21. Everybody good so far? Then I just get x equals log base 2 of 21 minus 3. And I had you put page 70 up there with your page number. If you wanted to go at some point and compare your answers, you'll see that you're getting the exact same answers, but they're probably on the other side of the equal sign, which for equations doesn't matter. Inequalities, it's going to make a little bit of a difference. Any questions at this point? All right, so now here I've gotten to a point where now I've got a variable in the exponent. I need to introduce a log to get that out. If I want log base e, what do I write? Natural log. So it's got natural log, so ln of both sides. So this gives me the natural log of 5/2, and that's equal to the natural log of e would just leave me with x. Okay. So I do think this is probably a little bit better, and maybe next year I can actually remember to teach it this way first, because then you don't have to remember about how to go around the equal sign and all that good kind of stuff. It's just kind of there and everything stays. We're good so far? Okay, so here we started with exponentials. We had to introduce a log. For these, we have logs, so we need to make them into exponentials. What we would have done here would be 3 to the third equals x plus 3, right? But if I have log base 3, I can just exponentiate them. It's a fancy word, meaning I'm going to make them both the exponentials, and the base of the exponential is 3. You can just kind of write it like that. See how they now look like exponents? And if you look on the third thing we wrote at the very top, if I have 3 to the log base 3 of something, that essentially goes away. That leaves me with x plus 3 equals 3 cubed. What is 3 cubed? 27. So that means that x equals 24. Any questions about where anything is coming from? Do you see the difference in how to do it and how to decide what to do? So B, what am I going to, I have a log, I need to make it into an exponential. What's the base of the exponential going to be? 5. So 5 is down here. Okay, those essentially go away, and I get 2x minus 1 equals 5 squared. And then the rest is just algebra. 5 squared is 25, so I get 2x equals 26, x equals 13. All right. Any questions? All right, so now I want to exponentiate this last one. What's the base of the exponential going to be? E. So I'll put e down here. Those essentially go away, and I get 2 minus x equals e to the 5th. So negative 2 equals e to the 5th minus 2. Oh, no, it's not negative 2. I'm so sorry. That should be a negative x. I'm going to warn y'all, it was a hot mess third period. I kept writing the wrong thing. I wasn't teaching it wrong, but I don't know where some of my numbers were coming from. My letters, it got better last period, but it still wasn't great. Negative x, so that gives me x equals negative e to the 5th plus 2. So when I'm not on my A game, you have to be. Catch me before I do something real stupid. Any questions? Okay. I didn't want to show you this new to you way in the middle of new information because I didn't want it to confuse things. So we're going to use this process today instead of going around the equal sign so you can kind of get the hang of it. Okay, we good? All right, great. So grab your other piece of paper. This is going on page 75 when we're done. And so previously we've done inverse functions. It's all business. If I'm going to find an inverse function, I have the equation. What's the first thing I have to do? Switch the x and y. Very good. Got to switch x and y. That's important for you to think of right now because we've been converting logs to exponentials and vice versa kind of a bit. And sometimes when we get into inverses, people get them all confused. It's not an inverse unless you have switched x and y. Just because you convert it doesn't mean it's an inverse. You have to switch x and y then convert it, that's what makes it an inverse, okay? Just to try and keep it all straight in your brain. Okay, so here are your general forms, all that good stuff again. How to find them, we switch x and y, we know that. We use inverse operations to solve for y. Then we write the final inverse using correct notation. That's a step that a lot of you have been missing regardless of the type of function, because you get it, but the correct notation would be f inverse or whatever it is, whatever the letters are. Okay. All right, so let's do that on this one here. I want the inverse of this function, so I'm going to change my f of x to y. Then I'm going to switch x and y. So I get x equals 3 times 2 to the y plus 4 power minus 15. So I have switched x and y. I now need to solve for y. So I do that just like I would do anything else. What's the first thing I'm going to move? The 15. So this will be x plus 15 equals 3 times 2 to the y plus 4 power. Is my exponential isolated right now? No, because I got that 3 right there. So I need to divide by 3. When I divide by 3, will I get x plus 5? No, I will not. I get x plus 15 over 3. And that's equal to 2 to the y plus 4 power. Now, sometimes at a step like this, and it doesn't matter if it's exponentials or what, some of y'all will simplify this left-hand side and make it like 1/3 x plus 5, which is 100% correct, but 100% unnecessary. So since it is not necessary, don't do it, because that's where sometimes we do weird things, or we actually make it more difficult on ourselves. It's not necessary, and you're wasting precious seconds you might need on something else, right? We're just going to leave it. We don't care if it looks weird. Okay, but now I do have this isolated, and since it is isolated, I need to get the y out of the exponent. Since it is an exponential, I have to use a log. What's the base of the log going to be? 2. So I'll do log base 2 of both sides. And there's not room usually on the right-hand side for you to write it properly, and that's okay. So what I'm left with on the left is log base 2 of x plus 15 over 3. And then the log base 2 of 2 leaves me with just y plus 4. Move the 4. So I've got log base 2 of x plus 15 over 3 minus 4 equals y. So step 1 was to switch x and y. Step 2 was to solve for y. Step 3 is use the correct notation. So this is f inverse of x equals log base 2 of x plus 15 over 3 minus 4. Okay. What questions do you have? We good? Okay. So we're still doing the same, like we've already been converting. We've been doing this stuff. And right now we're just switching it and then we're converting and all that kind of stuff. All right. So I'm going to make this y because I'm going to find the inverse of this one. So this will give me x equals negative 3 times log base 5 of y minus 4 plus 6. That's the first time all day I actually wrote y minus 4 and not x minus 4. I was changing them all to x's. I caught myself both times, but still. All right, so now they're switched. So now I've got to isolate my log. I'm going to start by subtracting 6. X minus 6 equals negative 3 times log base 5 of y minus 4. Now with that negative 3 there, I have a couple options. I could make that negative 3 an exponent, but if I don't have to, why the heck would I want to, right? Like I don't have to here. So instead I'm going to divide, and I'll get, what? So what did you say? Divide by negative 3. So x minus 6 over negative 3 equals log base 5 of y minus 4. Okay. Now my log is isolated, right? And I don't care if my negatives are weird. Like on the left-hand side, I don't need to clean any of that stuff up. Don't try and be fancy. Just leave it, okay? I need to get this out, which means I need to use exponents or make them into exponents. So what's the base going to be? 5. So I'm going to put a little 5 here on both sides to show what I'm doing. That leaves me with 5 to the x minus 6 over negative 3 power equals, so that goes away, y minus 4. So 5 to the x minus 6 over negative 3 power plus 4 equals y. Okay, step 1 is in green, step 2 is in blue, step 3 is, what's the name of this guy? Yeah, g inverse of x, 5 to the x minus 6 power over negative 3 plus 4, and that's that. Okay. Now, to point this out, because this was a question a few times earlier today, these processes looked different, right? But here, on the example 1, I had an exponential, and I had to get the variable out of the exponent. That's why I used the log. Here, I had a log, had to get the variable out of the log. That's why I used the exponent. Okay, so they're just kind of opposite processes there. That's how you decide which one to use. Whichever one's going to be the opposite of what you need. Okay. What questions do we have? Anything? Okay. All right. So let's look at example 3 then. We've got h of x. It tells me that k of x is h inverse of x. And I want to know for what values of x does k of x equal 1? Well, since k of x is h inverse and I have h, I'm thinking the first thing I need to do is find h inverse. Would you agree with that? Okay, so we're going to make this into y. So I'm going to get x equals 3 to the y plus 1 power minus 2. Add 2. That's equal to 3 to the y plus 1 power. Since I need to get the variable out of the exponent, what do I need to introduce? A log. Log base 3. Very good. So this will be log base 3 of both sides. So that leaves me with log base 3 of x plus 2 is equal to y plus 1. Everybody good so far? So then log base 3 of x plus 2 minus 1 is equal to y. And this, because I started with h of x, is h inverse of x. And since it's not my final answer, I'm kind of writing that for myself. Writing it just like that is fine. Okay. Any questions at this point about where anything came from or anything? Okay. So now here it says that k of x is equal to h inverse of x. That is this right here. That is log base 3 of x plus 2 minus 1. Okay. And I want k of x, which is this, to equal 1. So log base 3 of x plus 2 minus 1 equals 1. We okay with that? So then I'm going to add 1 over there. So I get log base 3 of x plus 2 equals 2. I have my log isolated. I need to get the variable out of the log. So what do I need to introduce? 3. 3 is the base to the exponents there, right? So this is going to, that essentially goes away, and I get x plus 2 equals 3 squared. 3 squared is 9, and that means that x equals 7. But we just solved a log, right? If I find x in a log equation like this, I have to check for extraneous answers, right? Because we have a restricted domain. So I have to take this 7, substitute it into the original, and make sure that I'm going to take the log of a positive number. If I put 7 in there, am I taking the log of a positive number? Yep, then x equals 7 works. Okay. What questions do you have? Anything? Okay, then. Just keep rocking along. Okay, so now we're on to inequalities. And we have previously done inequalities with polynomial and rational functions. We found all the x's. If we had asymptotes, we did that, all that kind of stuff. And that led us to a sign chart. Essentially, for you, I would say every time you have an inequality, you're going to end up with a sign chart. Okay, we okay with that? So that's how you know to do that. Let's look at this because there's a few extra little things we got to do in here. And I'll tell you why we want to do it the new way when we redo stuff. Okay, so it says we have f of x. I want the values of x for which f of x is greater than 0. Okay, when is f of x greater than 0? I'm going to show y'all a graph in a minute. And in my brain, I thought I was showing you this graph for this one, and I was like, that is less than 0, not greater than 0. Wrong question. Sorry, that's why I had a little pause for confusion there. All right, so I'm going to take log of x squared minus 4x plus 7 minus log of x plus 3 is greater than 0. Okay. Now, I have 2 logs, same base being subtracted. I can combine that into 1 log with what kind of operation? Division. So that's log of x squared minus 4x plus 7 over x plus 3, and that is greater than 0. Okay. I have lots of x's inside my log. I need to get them all out. So I need to introduce an exponential. I need to make it into an exponential. What would the base be? 10. So this is 10 here, 10 here. So that essentially goes away, and I'm left with x squared minus 4x plus 7 over x plus 3 is greater than 10 to the 0 power. Good. And 10 to the 0 power is 1. Be very careful, because one of the biggest mistakes made on these is that your brain sees 0 and you got 10 and 0, and if you're not thinking about it as an exponent, you put 0 and then everything goes downhill from there. Okay, so this is 1, right? And so since it is 1, I can get rid of this denominator. I can multiply both sides by x plus 3, get x squared minus 4x plus 7 is greater than what I multiply, because it's 1. If it was 2 or something, I'd have to distribute and be careful. But this is just x plus 3. Okay. So now I have a quadratic. I want to move it all to one side, so I'll move it all to the left. This will give me x squared minus 5x plus 4 is greater than 0. Now I got to figure out what my x's are to put on my number line. So what do I need to do with that? Factor. So I need to factor x and x. What are my numbers here? 4 and 1. So negative 4, negative 1. So my x's are 1 and 4. Okay. So 1 and 4 are what go on my number line. And these are open circles because it's greater than and not greater than or equal to. Okay. Then I'm going to do my signs here. So if I use something less than 0, less than 1, I'll use 0. So that give me negative, negative. That makes it positive overall. Between 1 and 4, I could do 2. So that'd be negative, positive. That's negative overall. 4, I could do 5. So that'd be positive, positive. That makes it positive overall. Okay, we all good with that? Use these a lot. Should be experts. I want it to be greater than 0, which means I'm looking for the positives. So it looks like I'm looking at this stuff here, right? But before I go write this down, these are logs. We have restricted domains. We have to actually look at the domain. On the very first log equation we solved last week or whatever it was, I showed you how to find the domain and we can make sure it worked. And then I told you for those, we don't have to do that every time. You just, like we did on the front, you get that 7, you plug it in, make sure you get a positive number, all is well. But these are intervals of an infinite amount of numbers. We can't plug all those in, right? So we need to actually look at the domain. And I need 2 things to happen. I need for this to be greater than 0. So x squared minus 4x plus 7 has to be greater than 0. So we'll start with that one. Try and factor that. Got x and x. I need 2 numbers that multiply to give me 7, combine to give me a negative 4. There's nothing, right? Now, that doesn't mean I just don't have an answer. It just means it doesn't factor. You just have icky answers, right? So how else can I find my solutions? It's another option. Graphing is an option, but we're not going to use that. another way? Quadratic formula, exactly. Here's your earworm for a while. You can sing along. It's quite entertaining.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2.
And if you can sing it in your head, and then you're going to know it when you need to write it down, right? Or you can sing it out loud.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
The last one's the best.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
At this time, you need to take a second to be thankful for YouTube videos so that you don't have to listen to me sing, okay? Because that would be horrific. All right, but yes, quadratic formula. So here's the truth about quadratic formula. It happens a couple times here. I think it even happens on your assignment. But the material that I have seen that comes straight from College Board, I haven't been able to see an actual test except for the FRQs. On the FRQs, you haven't had to do it for sure. The practice exams, the questions in AP Classroom, I have not seen any so far where you have to actually use quadratic formula for anything. But in the list of background knowledge and skills that you have to be successful in this class from College Board, quadratic formula is on that list. So it's fair game. It could show up. That's why I'm leaving these in here, even though I haven't seen any, and just tell you they're not always going to all be this complicated, because we need to see, it's okay to see complicated things, all right? If it's not going to be the end of the world if you cannot remember quadratic formula on the AP exam, because I would imagine at most one question, if at all. You with me on that? Okay, so let's do that real quick. We're going to figure out what our x's would be here. So x is equal to negative b, so that's 4, plus or minus the square root of b squared, so that's negative 4 squared, minus 4 times a, which is 1, times c, which is 7, all over 2 times 1. Now, before I just get in there and start doing stuff, I want to take a second to look at what I have, think about what different parts of the quadratic formula tell me. The part that's under that square root tells me a lot. Can anybody remember the name of the part that's under the square root? No, it has a name. It starts with a D. That would be, no, because that's in the numerator. I've gotten that every period. The discriminant, does that sound familiar? Okay, the discriminant. So you look at the discriminant here. So let's just think about what this is. Negative 4 squared is 16, right? And then 4 times 7 is 28. So I'm going to have 16 minus 28. That gives me a negative 12 under the square root, right? If I have a negative number underneath my square root, what does that tell me about my x's? They're not real, they're imaginary. So I have no real solutions, okay? And so that means that, okay, think about this. Does this quadratic, because that's a quadratic, we know it looks like a parabola, right? Does it open up or down? Up, because a is positive, right? So if I have no real solutions, that means it does not cross the x-axis. It looks like something like that. So that tells me that no matter what x I substitute in here, no matter what real number I put in here, I'm going to get a positive number out. And that's all I care about, is am I taking the log of a positive number? You with me on that? So I have no restrictions from this one. But then here, I also need for x plus 3 to be greater than 0. So that means x has to be greater than negative 3. If I come back over here and look at my number line, if I was to write down my intervals now, I would have written negative infinity to 1. But x has to be greater than negative 3. So there's a negative 3 here. None of this stuff works. So I only get to go from negative 3 to 1 and from 4 to infinity because of the domain restriction. Does that make sense to you? So it was like just a little bit of an extra thing with logs. So that means I'm going to go from negative 3 to 1. Everything's open because those were open circles, and this is open here. And then I'm going to go from 4 to infinity. Okay. What questions do you have? We good? Okay. Let's look at 5. On 5 here, we've got g of x and h of x. And then it says, what are the values of x for which g of x is less than h of x? So I'm just going to do exactly what it says. G of x is the natural log of x squared plus x minus 5. And I want that to be less than h of x, which is the natural log of x plus 4. Okay. Now, when we were solving equations, if this was an equal sign and I was trying to solve it, then I have a single log on each side. At this point, I'd get to drop the logs and move on, right? So the same thing happens here, but now I'm going to kind of show you why. If we want to think about doing it like the new way we learned today, what I would do would, what's the base of a natural log? E. So I would change them into little exponentials here like this. But look what happens. That goes away and I'm left with x squared plus x minus 5. That goes away and I'm left with x plus 4. That's why you get to just drop them. Okay, because remember I told you when I said you could drop them, there's no magic, there is math behind it. But now we have that. So now, again, I have a quadratic, going to move everything over to the left. So I'm going to get x squared. The x is 0 out to get minus 9. And that is less than 0. So is this easy or difficult to factor? Easy. Okay, this is x plus 3, x minus 3, because it is a difference of squares, right? So my x values are -3 and 3. And that's what's going on my number line. And they're open circles again. So to test my values, I'm putting it in here, right? Because this is what I just factored to do that. -4, that'll give me negative and negative. That makes it positive overall. Here I can put in 0. That'd give me positive and negative. That's negative overall. 4 would give me positive and positive. So that's positive overall. Okay. Everybody good so far? And I want it to be less than 0, which means I want the negative part, which means I'm looking at that right there. But I'm not just going to write down from -3 to 3 because this is a log and I have to check my my domain. So let's do the easy one first. I know that x plus 4 has to be greater than 0. So x has to be greater than -4. Is that going to affect me writing down -3 to 3? No, because -4 is down here. Everything I would write down, it's above that, so that's good. Like if I was doing the positive ones, it would make a difference, but for the negative, it doesn't make a difference. You with me? All right. So then I'm going to do, I got to do x squared plus x minus 5. I need that to be greater than 0. So does that factor? No. So we're doing quadratic formula again. X is equal to -b, so it's -1 plus or minus the square root of b squared minus 4 times 1 times -5, all over 2 times 1. Is my discriminant going to be negative or positive or 0? Positive, right? Because the -4 and the -5 is a positive 20. So that means that I'm going to have to pay attention to what this is now. So I get x is equal to -1 plus or minus the square root. So this is 20 plus 1, so it's 21 over 2. Now, we could estimate this. And again, I truly believe that if a quadratic formula came up, it would work out semi-nicely. It wouldn't be all weird and ugly like this. But I left it in here on purpose because I want to look at some of the graphs and things to kind of help you make sense of this. Because if I estimate this, what you can do, even like a rough estimation, you're going to know that both of these fall in here, okay? And they do, and that would be fine, and we'll figure out what to write with that. But let me just show you what's happening here with this. So first of all, this is the quadratic that we just did the quadratic formula with, okay? And so our decimals are actually -2.79 and +1.79. So they do exist between -3 and 3, okay? Here is the left-hand side, the blue one, okay? And this is the right-hand side of this part right here, okay? And we want the blue, we want the blue to be less than the green. So when is the blue less than the green, right? starting here and here. And you see how it's from -3, and actually that's not there, I'm sorry, there and there. -3 to 3, right? And it looks like, okay, yeah, it's less than that. The problem is we got asymptotes here. And those asymptotes are at the point where we get those numbers from the quadratic formula. That's why we don't get to go all the way between there. If I show you this right here, this actual thing, oh wait, if I actually did this and I subtracted it over, like when I do that, if I want to make them equal or less than or equal to each other or whatever, and I make it into one function, it looks like this. And you have these vertical asymptotes right here, and this is that's at -3, but then the asymptote that you never see on there is the other place. So that means that my asymptotes are in here, and this is what they are, and there's nothing in between them. So we are going from -3 to -1 minus the square root of 21 over 2. And then we start back over at -1 plus the square root of 21 over 2 and go to 3. Okay. And again, I don't want you to get inside your head and be like, this is crazy, weird, and hard, and not even try and do your assignments. I did the weird ones with you so we can at least just talk about them. Okay? What questions do you have? Anything? Okay. Don't let your brain shut down. We'll do some more together too. All right, so let's look at example 6. I got k of x. I want to know what are the values of x for when k of x is less than or equal to -31. All right, so 1 minus 4 times 2 to the x minus 3, that's the k of x. I want that to be less than or equal to -31. All right, so now I got to move that 1. So I'm going to get -4 times 2 to the x minus 3 is less than or equal to -32. Is my exponential isolated? No. So I need to divide by -4. When I do that, besides just dividing, what else do I have to do? Flip the sign. If you multiply or divide by a negative, you flip this sign around. Okay? And that is less than or equal to 8. And let's just pause real quick. What I don't think I made a point of is by doing it this way, instead of going around the equal sign that isn't the equal sign, everything stayed on the same side of the inequality sign, where if I did 10 to the 0 equals this, then I would have to remember to flip my sign, okay? And I don't want to have to do that. That's why doing it this way works out better for those. I don't think I made that point when I was there, and I meant to. Okay, so I'm going to give you a second. I want you to solve this while I hand out the assignment, and then we will talk about it. We'll work through it together. No, absolutely not, because I don't have time to write out a pass. Okay. Hopefully I gave you enough time to at least get it started, because I'm afraid they're going to come on with announcements. Whatever you wrote down, when I start talking and writing, do not erase or scratch out anything you have, okay? So if I was to go and do my next steps here, what would you do? Log base 2, okay, which is not wrong, okay? Not wrong, but let me show you something else. And then I'm going to do the log too. That's why I don't want you to scribble it out. I could rewrite this as 2 to the x minus 3 is greater than or equal to 2 to the third. Do you agree with that? Yeah. So then x minus 3, because then I can do log base 2, right? Log base 2, and then I get the x minus 3 is greater than or equal to 3, so x is greater than or equal to 6. Okay? Now, do not erase. Now let's look at the log one. Okay? If I came in here and did log base 2 on both of these, right? So on the left, I would get x minus 3 is greater than or equal to log base 2 of 8. So x is greater than or equal to log base 2 of 8 plus 3. Now, you are expected to simplify everything when you can. And you can simplify log base 2 of 8 because you can rewrite it as log base 2 of 2 to the third plus 3. And look, log base 2 of 2, that gives you x is greater than or equal to 3 plus 3, which is x is greater than or equal to 6. So doing the log, and so the point of what I'm trying to make here is before you just jump in and do the same thing you did on the question before, ask yourself if there's other ways you have done things, and sometimes it makes your life a little bit easier so you don't have to get into something like this, okay? You okay with that? Questions? All right, I know that was long. I'm sorry, but I've split all this stuff up as much as I can.